Hey everyone, we're going to take a look at number 10 in section 2.2. We're going to evaluate a limit numerically. Almost forgot that. That's important. Or state that it does not exist. And this is the limit we're looking at. Again, there's some information in the parentheses in the problem you need to carefully read. So again, when we're doing numerically, we're going to construct a table of values. Again, they don't give you the table here, so you're going to have to come up with your own table. We're getting close to 1. That means from below what I might begin, 0.8, 0.9, closer to 1, 0.99, 0.999, 0.999, and so on, right? Getting closer to 1 this way, right? And when I use my calculator to evaluate this, here's the expression. And making sure under table setup that I am independent mode is ask, but dependent is auto. I can now plug in my own values, and that's what I've done, and I get the outputs. And so here's the value, and notice by the time I get to 0.99, I get -1 E6. Remember that E in the calculator means scientific notation. This is -1 times 10 to the 6th power, which is a 1 with 6 zeros after it, right? So it's -1 million. And as we continue to do that, right, notice we go up by a factor of 10 to the third by a factor of 1,000, or go down because it's getting more negative, notice, but it's getting more and more negative, right? So think about what the limit might be as we approach 1 from below. Okay, from this table. We'll say that in a minute. I also want to approach 1 from above, and so there I'll start at 1.2 maybe, and then closer is 1.1, and closer is 1.01, and so on, getting closer and closer. And I did these values in there as well. And there's some symmetry here. It's like we're getting the same values, but they're opposite signs. Notice they're always positive. Okay, so think about what's happening as x approaches 1 from the positive side or from above. What's happening to this function? What is it trying to approach? Okay, well, what is the limit as x approaches 1 from the negative side, from this? Well, clearly it's approaching, we would say, negative infinity, right? That's what the notation we use, the infinity symbol, meaning the limit is unbounded. We continue to drop down in this case, right? In other words, as the function is approaching 1 from below, the graph, let's actually do that. So clearly this function has a vertical asymptote at 1, and as we approach 1 from this side, we're dropping down to minus infinity, right? So that's the limit as we approach -1. As we approach positive 1, sorry, as we approach 1 from the negative side, not -1, excuse me. As we approach 1 from the positive side here, clearly, right, these values are getting unbounded, but always positive. We're going to infinity, so the graph would look like, this here. Okay, graphically, that's what we have. But what does this mean about the limit? Well, it means the limit does not exist. If both limits went to infinity, in other words, if both sides went up this way to infinity, we could say the limit was infinity. We would use the infinity symbol in that case. But in this case, clearly the limit does not exist. And in the parentheses, they'll tell you to write D, capital DNE for does not exist. That's the same thing I ask for as well on tests. Okay, hope this one makes sense.